We have a short basic discussion about your basic graphs and functions, and then we look at your piecewise functions. Um, in this section, first and foremost, what you're required to know and to understand is that there are some basic functions that exist, and what you need to be able to do is to be able to graph those functions and then use the graph of the functions to pull out the properties of those functions. Like, so for example, one of the most basic graphs right here is your f of x is equals to x cubed graph. To graph this function, I will make a table of values, x and y, and I will go -2, -1, 0, 1, 2. X is an independent variable. The more values you have, the better picture of the graph you get. When I plug in -2, I get -8, -1, 0, 1, and 8. And then if I have my axes, 0, 0, 1, 1, 1, 2, 8, -1, -1, and then 2, -8. And so the graph right here will look like a bendy straw. It will look like this. And clearly the domain for this function will be all real numbers. And the range for this function, again, would be all real numbers. The domain, because the graph goes out in the x direction forever. The graph keeps going wider and wider and wider. The range, because the graph goes up forever and the graph goes down forever. And so the range will be that's given right here. And so from just understanding and seeing the picture of the graph, you can understand and you can create and you can get the results, the properties of the graph, of the equation. Later on in the next section, we'll be using these graphs right here to go from here. Your basic graphs include, but are not limited to, y is equals to a constant. That right here is this is 5, it goes across this way. Domain, all real numbers. Range is just the value 5. And this is symmetric about the y-axis. And then your next basic graph right here is y is equals to x. That is this graph right here at a 45-degree angle. And the domain is all real numbers. The range is all real numbers. And it's symmetric to the origin. Then you have y equals x squared. That's your parabola. The graph is going to be halfway up and it starts going back, halfway down and starts going back up again. Your domain is all real numbers. Your range is the half number line, so that's 0 to infinity. That's symmetric to the y-axis. Then you have your y equals x cubed. The cube graph just did. Looks kind of like an S. I like to think of Superman when I think of this right here. Domain, all real numbers. Range, all real numbers. Symmetric to the origin. Then we have, no, we're doing y to the 4th power. Nothing. We have y is equals to the absolute value of x. The graph of this function looks like a V, one direction. Basically, it's the y equals x graph, but on the negative side goes back up. Your domain is all real numbers. Your range is only positive numbers. This is positive numbers and 0. The graph right here is even. Your next one is y equals the square root of x. Now for this graph in particular, I will do a table of values because there's a little trick that you need to know. If you have your x and you have your y values, and you want 0, 1, 4, 9, 16, you know, you go 25, because when you plug in these numbers, you can actually get the square root. Now this is taking multiple root only, we do not go plus or minus, that would not be a function. So when here you get what's called a half graph. The domain is from 0 to infinity. This graph has no root function. You take numbers, you can take the cube root of x, put a 3 right here. That graph right here, yes, but the domain is, and it's symmetric about the origin. All to look at. To master is this graph right here. Y is equals to 1 over x. The main reason is that it has fractions. This graph, let's go 5, 4, 2, 1, then 0, 4, 5. Notice how many more points I need for this graph right here. This will be 1/5, negative 1/4, negative 1/3, negative 1/2, negative 1. Cannot divide by 0, so it's undefined. UD 1, 1/2, 1/3, 1/4, 1/5. If you were to plot these right here, you get a graph right here that I like to say looks like two macaroni sticks. The graph never touches any of the axes. Bends around them, like kind of sort of, let's go straight. The domain in this graph is broken because there is no x value around. So your domain, and those are your major graphs. You gotta memorize all of them one at a time, and after you've drawn them enough times, start guessing at what each